we're going to look a little bit about simulation, drawing, and then into the CAM area. So let's talk a little bit about simulation. There's a lot of simulation built into Fusion 360. For people who are using the free license, either as a trial or as a hobbyist or startup, or if you are teaching students, it's important to be aware that these people have access to the ultimate version of Fusion 360, and there are very few differences, but the difference reside in simulation and in tooling on the CAM side. And in simulation, you have some basic simulation types that are in basic Fusion 360, including static stress, including modal, thermal stress. But in the ultimate version, there are 8 different types of simulation, including buckling, nonlinear stress analysis, so a lot of different operations and mechanical event simulations. Though it is important for you to note that for you Inventor users, the event simulation is different in Fusion 360 than it is in Inventor. In Inventor, it's more about if you drop a ball, it will bounce if it hits the steel plate and what happens. Event simulation in Fusion 360 will allow you to drop something on something else and will allow you to model how that object that got dropped on will break, how the material will release and tear and fragment. So pretty advanced stuff, in fact. When you get into those advanced simulation types, you no longer have the option of doing a local solve. So for a static, modal, thermal and thermal stress, the core simulation types, you have the option to do a local solve or a cloud solve. The more advanced simulations have to be done in the cloud. So people need to have cloud credits available. Though frankly, for what's being done, it uses pretty minimal number of cloud credits. We have the ability to modify the study setting, of course, do mesh refinements and size, set our boundary conditions, and take a look at interpreting the results. So there's a few bits and pieces that we can do there. Now moving back into Fusion. Now there isn't actually a specific, don't save that, a specific model for this simulation. So what I'm actually going to do, I'm going to go into drawings and I'm just going to load the drawing ones up. Now I have noticed when I've been doing this a couple of times that the model that we've got here, sometimes there is an error when we set up the stress analysis. And if that's the case, what I'll do when we come to showing the results, I'll just bob into another drawing that I've done and just show you the type of results that we can get out there. First thing I'm going to do is I'm going to change my display settings to shade with edges. So I'm just going to make sure that I got shaded with visible edges only, which is okay because that's my preferred way of working. And because we're doing a simulation and this is a read-only file, what I need to do is save as. I'm going to go to save as. I'm just going to save this into my own folder so that it will allow me to save and it will allow me to do the simulations afterwards. Then, next thing, just drop that down a minute. We're going to change model space and we're going to go into the simulation environment. Now you can see we've got lots of different options here that we can select. I'm just going to do the static stress and press OK. And just read that, yeah, just press OK that. What you will notice is the appearance of the model has changed to match the material. I'm going to expand the model components folder. So what we've got here, down the side here, you see where we've got model components, open that up, and you'll notice you can actually select each individual component. And what I'm going to do is turn off everything apart from the crank arm. So I'm just going to leave the crank arm on. And I'm going to right click. I could have actually just right clicked and there and done isolate, So that's the other option, rather than isolate, turning all them off. If I go right click, isolate, that's another way of actually doing that and getting that over. So that is how I'm going to filter what is being simulated here. We have the abilities to generate contacts automatically or manually. You'll notice a lot of commonality in Fusion 360 terminology, as with inventor analysis as well. Let's work through the line. So up at the top now, we've got a line. So we've started our new study, which we've got going here. Because I have all this text in the crank arm, so if I now, in my crank arm, zoom in, I've got the text in there, I've got the cutouts in, and the bushings and everything. What I'm able to do is I'm able to actually simplify the option. If you haven't been in Fusion for a while, this is a fairly new option. So what I'm going to do, into simplify, what I can do is select the two slots, go to that front view, box select, I don't want that one. There we go, that's got it, just removed it. And there's an edge there as well that I'm picking up that I don't need. That one, so I shift and select that. So I've now selected everything that I want to simplify. And then if I select remove faces, so I come on here and remove faces, then it's removed them faces from me. So it's actually got the text and it's taken the slots out of there, like that. So it's simplified this initial design. It's not changed the model at all, it's only making modifications to the geometry that is available in this simulation. We can also do the same with remove features, and we can remove various features from the component. So we can go around and we can remove different features in there. We don't need to get too carried away with this, as it's a fairly robust system. We can then click Finish Simplify. So click Finish Simplify. Next, I want to make sure I have the correct study material. I can also change the material properties. So if I click on here, Study Material, it brings me up with a dialog box. The model material here is a steel. We can change, so you've got a big catalogue there. Now what you will notice is, as we're scrolling down, if we come across a material that's got this like triangle graph sort of thing, that means it's got a non-linear material study. So we can actually pick materials that are non-linear to do the study with. What I'm going to actually do here is hopefully just pick a simple aluminium. Okay, so you notice the material has changed to match. I can now set my constraints. So what we've got here, so one tool here, yeah, we have a few different options. Let's just, on this crank arm, open it up. Let's get rid of the views of these bushings. We don't want these bushings in there. So if I now go to constraint, and I want the inside of that and the inside of that to be fixed, I can change the axis, the angle slightly. If I go OK, they are now fixed. On this side, now with my structural load, I can click on the inside there. I want to change from force to bearing load. I can change the angle of the bearing load. So if I'm spinning around here, there, I want it to be pulling outwards. There, so say an angle of minus 90 degrees. And say let's try a magnitude of 20 newtons in there. I've got the option to actually change the units if I want. So in there, I can change the units if I need to change the units. I can flip direction. There's quite a few options that I can actually change in there. So if I go OK, we have a pre-check option that comes up. Some warnings there, so pre-check. So missing 7 fully unconstrained grouping load. So that's automatic contacts. DOF select here manual contact. That comes up, but nothing really of any concern there. We also have the ability to see a display degrees of freedom view. So you can see if your model is fully fixed or not. This only looks like we're good and good to go. So if we go on here, degrees of freedom, click on there, you can see, yep, we're all green. Everything's green. We are now fully fixed and good to go. So close that. So now we can go to solve. We've got options to do in the cloud, got options to do locally. If I just want to do local now, and I press solve, and it will start running. So if I actually open up this dialog box, you can actually see what it's actually doing. So it's prepared the model, it's generating the contacts, it's doing the mesh. It's probably doing it a little bit quicker than normal because we're not joining a cloud queue by doing it locally. And hopefully, once it's completed the meshing, we might actually be able to get some results. Fingers crossed. Yeah, one thing to note, if you're doing this in the cloud, you can actually leave it and come back to it. And it will actually create it for you. As you can see, it's taking its time. I think we're getting there slowly. And it's complete. And yes, we've actually got some deformation here, or deformation. You can see, spin it around a little bit. Now we can see our results that we've actually got from it. You can see the different settings that you can view. So up in here, the results, yeah, safety factor targets, you can set them, recommendations, adjusted. So you've got options up there, but also down here, we can change to be a stress view. It gives you some options here. You can actually narrow down what you are actually viewing, or which zones you're actually viewing in there by using this magnitude up and down. You can actually reduce that. Displacement. Now it looks from this that there's a lot of displacement, but when you actually look at the actual figure of this, you know, it's 3.94 to the minus, is it -4? So it's, you know, there's virtually no displacement whatsoever on that. Reaction force here, strain, and contact pressure. One thing that it does do, which I quite like, up at the top with the results, you can actually animate them. You've got the option here to play in number of steps. Again, this is really exaggerated. You can stop, you can record it, you can have it two-way, so it goes backwards and forwards. You can change the number of steps. This is initially doing 10 steps. You can change that. You can change the speed, so you can change it to slowly. You can record it. So there's a lot of options that you can do. We can change the units that are being displayed for the stress. You know, if we change it to displacement, you know, these are millimeters. Yeah, what's it? You know, centimeters, meters. So there's a lot of things that you can actually do here to monitor and to view this. And you've got the ability to, if I cancel that now, if I just OK, you've got the ability to rerun the study with a different material. So you can just rerun the study on the same component using a different material, which is quite good because you then got a good comparison between the two. We go back to now. So we've done a little bit on demonstration. Yeah, it shows us a little bit of what we can do there. On our PowerPoint, which you'll have a copy of, it'll give you an idea of things that you can test and how to use it.